On September 8, 1900, Galveston Island occupied a sandbar 8 feet above mean sea level. The city contained no seawall, no elevated refuge, no drainage system designed for water arriving from the ocean rather than falling from the sky. By mid-morning, the Gulf of Mexico had begun to cross the beach at a rate that exceeded all historical benchmarks for the Texas coast. The tide gauges stopped functioning at 11:30 a.m. The bridges remained open. The island remained populated. The storm had not yet made landfall. Galveston Island in 1900 measured approximately 30 miles in length and no more than 3 miles at its widest point. The highest natural elevation was 8 feet 9 inches above sea level, recorded at the center of the developed urban core. Most residential streets sat between 6 and 7 feet. The eastern and western ends of the island dropped below 5 feet. Construction followed Gulf Coast norms, wood frame structures on piers or low brick foundations. Roofing was predominantly shingle or tin. The city operated 4 bridges to the mainland, all wooden trestle designs with drawspans for maritime traffic. No building codes addressed wind load or flood inundation. The island had experienced tropical storms in 1875 and 1886 without structural failure of the grid. Storm surge in those events had not exceeded 4 feet. The hurricane forming in the central Atlantic in late August 1900 passed over Cuba on September 4 with a recorded pressure of 931 millibars. It entered the Gulf of Mexico on September 6. The shallow continental shelf extending south from Galveston created optimal conditions for surge amplification. Water depth dropped from 200 feet to under 30 feet across a span of 40 miles. When sustained winds of 120 miles per hour began rotating counterclockwise around the low-pressure center, the Gulf's surface was pushed north and west. The slope of the seabed concentrated this displacement into a vertical wall of water. Barometric pressure at Galveston fell to 964 millibars by dawn on September 8. The Weather Bureau office recorded unusually high tide at 7 a.m. No hurricane warning system existed. The telegraph lines to Houston remained operational until 10:15 a.m. Flooding began on the beach side of the island at approximately 8:30 a.m. Water rose through the sand and crossed Avenue A by 9 a.m. Residents in the first 3 blocks began moving furniture to upper floors. The streetcar system suspended operations at 9:45 a.m. when water depth on the rails exceeded 6 inches. By 10:30 a.m., the Gulf had advanced inland to Avenue J, a distance of 9 city blocks. Wind speed increased from 60 miles per hour at 10 a.m. to over 100 miles per hour by 11 a.m. The tide did not recede. Conventional tidal cycles ceased to apply. The Weather Bureau anemometer failed at 100 miles per hour. Communication lines to the mainland were severed when the first bridge lost its eastern approach. Water depth in the central city reached 3 feet by noon. The island remained fully populated. Between noon and 6 p.m., the city experienced sustained mechanical demolition. Wind and water operated as coupled forces. Structures did not fail suddenly. They disintegrated incrementally. Walls separated from foundations. Roofs detached and became airborne projectiles. Wooden piers supporting houses broke in sequence as water depth increased and lateral pressure exceeded design tolerances. Wind pressure on walls created vacuum zones that pulled structures apart from the interior. Debris fields formed and expanded. Timber from destroyed houses became battering rams. Slate roof tiles became blades traveling at over 80 miles per hour. Duration became the determining factor. 6 continuous hours of force application eliminated the possibility of structural survival. No building type proved resistant. Brick performed marginally better than wood, but still collapsed when foundations were undermined by scour. Storm surge reached 15 feet above mean sea level by 3 p.m. The entire island surface was submerged except for isolated sections of the central business district where elevation reached 8 feet. Water from the Gulf met water from Galveston Bay. The island became a shallow reef. The street grid ceased to exist as a navigable system. Intersections were indistinguishable. Utility poles failed in clusters. Gas mains ruptured. The city water system lost pressure when the pumping station flooded. No drainage occurred. Water had nowhere to go. The Gulf continued to rise. By 5 p.m., only the tallest commercial structures on Market Street and Strand Street projected above the waterline. These buildings were 3 to 4 stories. Survivors clustered in upper floors. The structures swayed but did not collapse. Wind speed remained above 100 miles per hour until after sunset. Wooden houses built on piers began to float when surge depth exceeded foundation height. A typical single-story wood frame house weighed approximately 40,000 pounds. Displacement of that mass required approximately 640 cubic feet of water. When structures broke free, they drifted with wind and current. Velocity was sufficient to destroy anything in the path. Floating houses collided with stationary houses. Both were reduced to loose timber. The debris accumulated and formed mobile rafts. These rafts were driven inland by wind. They collided with multi-story buildings. Brick walls shattered. The rafts continued moving. Survivors on the rafts were carried across the island. Some rafts crossed from the Gulf side to the bay side. The process repeated throughout the afternoon. Structural density decreased from the beach inland. The city was erased in strips. All 4 bridges connecting Galveston Island to the mainland were destroyed by 4 p.m. The railroad bridge lost 3,000 feet of trestle on the island approach. The wagon bridge at the eastern end collapsed when debris struck the center span. The 2 western bridges were swept away entirely. No vessels could approach the island. The harbor was filled with wreckage. Navigation channels were blocked. The island was isolated. No communication, no transport, no resupply. Water and wind prevented movement even within the city. Survivors in intact structures could not reach other structures. The bay side of the island was covered with debris. The Gulf side was scoured to sand. Darkness arrived at approximately 7 p.m. Wind speed decreased to 80 miles per hour. Water began to recede at 8 p.m. The process was slow. On the morning of September 9th, the central and eastern sections of the island were covered by a debris field 3 stories high in places. Individual structures could not be identified. The field extended for over 40 city blocks. It consisted of compressed and interlocked timber, roofing material, furniture, brick fragments, and sand. Movement through the field was impossible without cutting. No streets were visible. The western end of the island had been stripped to bare sand. Foundations remained. Houses were gone. The beach had shifted inland by 2 full blocks. The bay shoreline had advanced by 1 block. Assessment teams could not form. No functional government buildings remained. The water system was inoperable. The gas system was ruptured in 4,000 locations. Telegraph poles were down across the entire grid. Bodies were located throughout the debris field. Recovery required weeks. Post-storm analysis documented wind speeds estimated at 145 miles per hour based on damage signatures and pressure gradients. Maximum storm surge was calculated at 15.7 feet above mean sea level at the beach. The surge remained above 8 feet for over 7 hours. Total building destruction was recorded at 3,600 structures. An additional 2,600 structures sustained major damage. The death toll was officially recorded as 6,000, though estimates ranged as high as 12,000 due to transient population and incomplete records. The economic loss was calculated at $30 million in 1900 currency. The city lost 60% of its residential capacity. The port facilities were destroyed. The rail terminal was inoperable. No structure south of Broadway Avenue remained habitable. Recovery required the complete reconstruction of infrastructure, water, gas, electric, and communication systems. The Galveston Grade Raising Project began in 1903 and concluded in 1910. It elevated the entire city by filling the surface with sand dredged from Galveston Bay. Over 500 city blocks were raised by heights ranging from 1 foot at the bay side to 17 feet at the beach side. Buildings were lifted on jacks. Sand was pumped beneath them. The seawall was constructed between 1902 and 1904. It extended 3.3 miles along the Gulf shore and stood 17 feet above mean sea level. The wall was concave, designed to redirect wave energy upward. The combination of grade raising and seawall construction constituted the largest civil engineering project in the United States at that time. The system was designed to prevent recurrence. Official documentation is maintained in the National Weather Service Archive and the Galveston Historical Foundation records.